Hi, welcome back to another one of my presentations. Today my report will be about the atmosphere of the Earth, a part of Earth I see and think is pretty magnificent. The atmosphere of Earth is the layer of gases, commonly known as air, that surrounds the planet Earth and is retained by Earth's gravity. The atmosphere of Earth protects life on Earth by creating pressure allowing for liquid water to exist on the Earth's surface, absorbing ultraviolet solar radiation, warming the surface through heat retention, greenhouse effect, and reducing temperature extremes between day and night, the diurnal temperature variation. By volume, dry air contains 78.09% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and small amounts of other gases. Air also contains a variable amount of water vapor, on average around 1% at sea level, and 0.4% over the entire atmosphere. The three major constituents of Earth's atmosphere are nitrogen, oxygen, and argon. Water vapor accounts for roughly 0.25% of the atmosphere by mass. Earth's atmosphere can be divided, called atmospheric stratification, into 5 main layers. Excluding the exosphere, the atmosphere has 4 primary layers, which are the troposphere, stratosphere, mesosphere, and thermosphere. From highest to lowest. The exosphere is the outermost layer of Earth's atmosphere. It extends from the exobase, which is located at the top of the thermosphere at an altitude of about 700 kilometers above sea level. This layer is mainly composed of extremely low densities of hydrogen, helium, and several heavier molecules including nitrogen, oxygen, and carbon dioxide closer to the exobase. The atoms and molecules are so far apart that they can travel hundreds of kilometers without colliding with one another. The thermosphere is the second highest layer of Earth's atmosphere. It extends from the mesopause at an altitude. The height of the thermopause varies considerably due to changes in solar activity. Because the thermopause lies at the lower boundary of the exosphere, it is also referred to as the exobase. The temperature of the thermosphere gradually increases with height. Unlike the stratosphere beneath it, wherein a temperature inversion is due to the absorption of radiation by ozone, the inversion in the thermosphere occurs due to the extremely low density of its molecules. This layer is completely cloudless and free of water vapor. However, non-hydrometeorological phenomena such as the aurora borealis and aurora australis are occasionally seen in the thermosphere. The mesosphere is the third highest layer of Earth's atmosphere, occupying the region above the stratosphere and below the thermosphere. It extends from the stratopause at an altitude of about 50 kilometers, 31 miles, 160,000 feet, to the temperatures drop with increasing altitude to the mesopause that marks the top of this middle layer of the atmosphere. It is the coldest place on Earth and has an average temperature around 85 degrees C, 120 degrees F, 190 K. Just below the mesopause, the air is so cold that even the very scarce water vapor at this altitude can be sublimated into polar mesospheric noctilucent clouds. These are the highest clouds in the atmosphere and may be visible to the naked eye if sunlight reflects off them about an hour or two after sunset or a similar length of time before sunrise. The stratosphere is the second lowest layer of Earth's atmosphere. It lies above the troposphere and is separated from it by the tropopause. This layer extends from the top of the troposphere at roughly 12 kilometers, 7.5 miles, 39,000 feet, above Earth's surface to the stratopause at an altitude of about 50 to 55 kilometers. The stratospheric temperature profile creates very stable atmospheric conditions, so the stratosphere lacks the weather-producing air turbulence that is so prevalent in the troposphere. Consequently, the stratosphere is almost completely free of clouds and other forms of weather. The troposphere is the lowest layer of Earth's atmosphere. It extends from Earth's surface to an average height of about 12 kilometers, 7.5 miles, 39,000 feet, although this altitude varies from about 9 kilometers, 5.6 miles, 30,000 feet, at the geographic poles to 17 kilometers, 11 miles, 56,000 feet, at the equator, with some variation due to weather. Although variations do occur, the temperature usually declines with increasing altitude in the troposphere because the troposphere is mostly heated through energy transfer from the surface. Thus, the lowest part of the troposphere, aka Earth's surface, is typically the warmest section of the troposphere. The troposphere contains roughly 80% of the mass of Earth's atmosphere. The troposphere is denser than all its overlying atmospheric layers because a larger atmospheric weight sits on top of the troposphere and causes it to be most severely compressed. Nearly all atmospheric water vapor or moisture is found in the troposphere, so it is the layer where most of Earth's weather takes place. It has basically all the weather-associated cloud genus types generated by active wind circulation, although very tall cumulonimbus thunder clouds can penetrate the tropopause from below and rise into the lower part of the stratosphere. The ozone layer is contained within the stratosphere. In this layer, ozone concentrations are about 2 to 8 parts per million, which is much higher than in the lower atmosphere but still very small compared to the main components of the atmosphere. Atmospheric pressure is the total weight of the air above unit area at the point where the pressure is measured. Thus, air pressure varies with location and weather. Because in an ideal gas of constant composition, the speed of sound depends only on temperature and not on the gas pressure or density, the speed of sound in the atmosphere with altitude takes on the form of the complicated temperature profile. Air pollution is the introduction into the atmosphere of chemicals, particulate matter, or biological materials that cause harm or discomfort to organisms. Stratospheric ozone depletion is caused by air pollution, chiefly from chlorofluorocarbons and other ozone-depleting substances. Blue light is scattered more than other wavelengths by the gases in the atmosphere, giving Earth a blue halo when seen from space. The geomagnetic storms cause beautiful displays of aurora across the atmosphere. Limb view of Earth's atmosphere. Colors roughly denote the layers of the atmosphere. Earth's atmosphere backlit by the Sun in an eclipse observed from deep space on board Apollo 12 in 1969. Well, that's all for now. Can't wait to start my next presentation. Bye, and don't forget to like and subscribe for more updates and research from HoloLena.